explain the concept of attention in LLM and how it is implemented. Answer attention is a crucial concept in large language models LLM that enables them to focus on specific parts of the input sequence when making predictions. This is particularly important in natural language processing tasks, where the input sequence can be long and contain irrelevant information. The attention mechanism allows the model to dynamically assign weights to different tokens in the input, highlighting the most relevant ones for the current task. The attention mechanism is implemented using self-attention, which is a key component of the transformer architecture. Self-attention calculates attention scores for each token relative to all other tokens in the sequence. This allows the model to capture dependencies between tokens, regardless of their distance. In other words, the model can attend to information that is not immediately adjacent to the current token but is still relevant to the task at hand. The self-attention mechanism works by first transforming the input sequence into three linearly transformed vectors: the query vector Q, the key vector K, and the value vector V. The query vector represents the information that the model is trying to extract, the key vector represents the context in which the information is being extracted, and the value vector represents the actual information being extracted. The attention scores are then calculated by taking the dot product of the query vector and the key vector and applying a softmax function to normalize the scores. The attention scores represent the weight that the model assigns to each token in the input sequence. The weighted sum of the value vectors, calculated using the attention scores, is then used to compute the output of the self-attention mechanism. This process is repeated multiple times, with the output of each self-attention mechanism serving as the input to the next. This allows the model to capture long-range dependencies and relationships between tokens in the input sequence. The final output of the self-attention mechanism is used to compute the output of the transformer architecture, which is then used to make predictions. In summary, attention in LLM is a mechanism that allows the model to focus on specific parts of the input sequence when making predictions. It is implemented using self-attention, which calculates attention scores for each token relative to all other tokens in the sequence, and uses these scores to compute the output of the transformer architecture. This enables the model to capture dependencies and relationships between tokens in the input sequence, regardless of their distance.